Hey everyone, final example for Unit 3 and this semester. A poll conducted at a U.S. university classifies respondents by whether they live on or off campus and their political party. The results were investigated for evidence of an association between campus living status and party affiliation. So we've got association, which is the indicator that we're trying to figure out if something's independent or dependent. And here are our two variables, campus living status and party affiliation. Also, this is a contingency table. So there's a couple things we can note right away. First, that means this is a chi-squared test for independence. And then up here, we can remember that our row by columns are going to be really important. In this case, that's 2 by 3 for when we go and put this into the matrix feature in the calculator. But first step, write our hypotheses. So I underlined the two variables up in the paragraph above on purpose, right? Campus living status and party affiliation are, I'm going to abbreviate, are independent. And I'm going to draw a line here so this doesn't get confusing. Okay. And then we'll do the alternative. Campus living status and party affiliation are not independent. Okay. Are the conditions for inference satisfied? The first condition, well, let's go independence and randomization is always the thing we check first. And here, there's no sampling method mentioned. So we cannot conclude that this condition has been met. We still check the others. The second is counted data. Are the observed values counts? Like, are they whole numbers that are positive? The answer here is absolutely yes. The next question here is, what are the expected cell frequencies, right? Expected cell frequency. And here, we're actually going to, I'm going to give you like a little heads up. We're actually going to wait to check B, matrix B, right? Until after the test. So the third condition, expected cell frequency, actually cannot be checked until after this test has been complete, the way that we use our technology. So now we're going to go to our calculator, go to second, X inverse, use the matrix menu to arrow to edit, change your rows and columns to 2 by 3, and enter the data from the matrix above. Then go to stat and test and run your chi-squared test, making your observed equal to matrix A and your expected equal to matrix B. Once we do this, we get a chi-squared value of 4.8512. That's our test statistic. And we get a p-value of 0.0884. And here, we're given our alpha, so we'll go ahead and move it right next to where we are there. And we want to compare that, and we find that it is, in fact, greater than our alpha level. Okay, so what do we want to do? We want to make our conclusion. Sorry, I'm also on Zoom with someone at the moment. We want to make our conclusion, but based on failing to reject. Okay, what we say here is there is not enough evidence to show that campus living and party affiliation are not independent. So we're rewriting, if we can spell it, we're rewriting our alternative hypothesis always. Now that the test is over, go back up into your calculator, check matrix B. All the counts are greater than or equal to 5 in matrix B. And please access that the same way you would do for matrix A, by hitting second, X inverse, arrowing to edit, and checking what the values are after the test has been run. Best of luck, everybody. Ask me questions down there in the comments.